Hello, everyone. Welcome to my podcast series, Sayed on Air. Today is our third series of the podcast series. Today, we are going to discuss about advancement in food health through pediatric information modeling, parametric design, and 3D printing of orthopedic footwear. Today, we have a special guest, Dr. Daniel Petcu. We'll be discussing how he sees this advancement in food health goes through pediatric information modeling, parametric design, and 3D printing of medical devices, which allows us to personalize the footwear for individuals. Dr. Daniel Petcu is all the way from Romania. He is a footwear engineer having a PhD in medical field, and his special focus is on parametric design and 3D printing of orthopedic footwear. As I mentioned earlier, his pioneering work is in parametric design, which is some kind of new in pediatric field or medical device field. And also he is a great enthusiastic in 3D printing, utilizing different printing technique, slicing before printing, and also introducing different printing technologies, different materials. And he is a very active member in 3D printing society for medical devices. I'm very excited to welcome all the way from Romania, Dr. Daniel Petcu from his native city of Bucharest. Dr. Petcu, welcome to my podcast series. And I understand it is 7 a.m. in your city. Thank you for making the time. And
Yes.
let's join us. How has your day been so far? That's
Okay.
great.
Thank you very much for your invitation. I'm glad to be here, especially because I know you are the first pedortist from Australia who has a PhD, and I want to congratulate you because
Thank you.
I think this is important for this complex profession. I think this complex profession deserves much more scientific study and much more people involved in the PhD program. Take you into consideration my work. Maybe could look a little complex, this work, but I am sure it's not complex as it looks. So maybe in the future, with the help of many people interested, I hope
Yes.
to change a little, to add a little to the profession. So my work is not about giving up with the traditional method, but we taking what is valuable for this traditional method and transfer it into new knowledge. So thank you very much. I hope this podcast to be of interest for your audience.
Good. I'm sure it will be, Daniel. I have seen a lot of your presentation in a lot of international conferences. It's a new. It sounds a bit complex, but it is very interesting when someone gets into it, and it says when they understand the value of it and what the changes it's going to bring for the profession, the web orthopedic footwear practice is, how the devices are manufactured, how they can be improved further. I'm sure it will be very much engaging and enjoyable for everyone. Okay, now we are coming to the main discussion point, Daniel. I know you are very big and very much focused on the periodic information modeling and parametric design and 3D printing for medical devices. You're a great enthusiast. And I have seen that you have been wearing the shoes that you designed and you 3D printed. That was amazing to see. So I was lucky enough to see them in person in Cologne. So I think not many people had the privilege
Yes.
to see that in real. So,
And
but
also in Leipzig this year.
great. Did you bring them into Leipzig also, Daniel?
Yes, this year.
Okay. Yes, fantastic. Yeah, now I remember. Yes,
Yes,
that
yes.
was the cream color. The cream color. Okay. Okay, Daniel. Probably we need to let the audience know a bit
Okay.
more about how uh, what it means, the periodic information modeling in a simpler term, so they understand what we are talking about and how that's going to actually benefit them. So let's discuss about periodic information modeling, parametric design, and then we can lead the discussion into 3D printing footwear. So if you give us some starting point about the parametric design, please.
Okay, so here if we can see the first image, I would like to see the first image. Okay, thank you. So in this work of parametric design, I was inspired by a workshop seen on the Rhino forum, which was about Hotel Morpheus. And it was fascinating for me because such a complex problem was solved by many teams with the help of one software. It was about communication, it was about new technologies in a concept which already exists. It is called building information modeling. So I thought, what if this building information modeling will be translated to pedortics? Because sometimes in pedortics we can have many teams, many people involved in a job, in a designing of footwear, but also, especially in this day when it is hard to find the workforce, we can have a few people or maybe one single people, as I am, which have to perform all the tasks. So in this way, I have discovered the parametric design, which means that for any task, we need some input data, which are transformed through a function in the desired outputs. Okay, so the idea is that we already make parametric design in our work. For example, in the traditional workflow, you can see here, what is the objective? Is to build with plaster some surfaces, because at the end, the cast, it is a sum of surfaces on which we will make the orthosis, okay? So what we'll do, we'll put a nail in order to mark how much plaster we have to add, okay? So practically in the traditional workflow, we are working one time with a physical model, and this can be the cast, the mold of the foot orthosis, or the cast of the shoe last, or the midsole, okay? While in the pedortic information modeling, we are working with what is called the informational model of the footwear. So practically with this model, we have a virtual shoe, a virtual footwear, which we can modify according to our purposes, our prescription variables. So it is simple here. Here we have some points which are generating some curves in some surfaces, and at the end the footwear. But the difference is that here when we are moving a point, we are moving all the surfaces, all the items which are defining the footwear. In the traditional work, if we have made a surfaces and we want to modify something, for example, let's say to lower the height of the nail, we have to grind, we have to modify. We are working just on foot orthotics or just on last. While in the second part, when we are modifying the position of one point, we are modifying all the parts which are connected instantly. So this can bring us much more time for us, much more variation, much more possibilities to achieve our goals.
Correct. And also, I guess the parametric design model is existing model, but heavily used in other industry, and you have pioneered to bring that knowledge into the orthopedic or medical footwear. Well done, Daniel. It's a great thing for the professionals.
I would say it's nothing new under the sun.
Great, well done.
But here we'll discuss the huge.
And I understand that here when we do use the parametric design, so we can see the changes. The changes are visible rather than in the traditional way. If we are adding plaster, then we don't see the base layer or the layer under that model. But in the parametric design, because it's digital, so we can color them, code them, we can shade them in a different color, the original and the modified version, so we can actually compare. So that makes a huge difference for the clinician or the designer to see the changes or see the modification. So, and that also resulting towards a much better fitting, much more
Yes, yes.
precision fitting devices. Fantastic,
More
Daniel.
than that, imagine you have finished the shoe, okay?
Yeah, yeah,
You have glued the midsole and the
yeah,
last is inside the shoe. And in that
correct.
moment, you want to make a modification. You
Yes,
can't grind the last having
correct.
it
Yeah,
inside the shoes,
yeah,
okay? But here you can modify the last
yeah.
and all the parts will be modified instantly.
Correct.
Instantly.
Correct. Correct. That's a huge time saving, saves a lot of effort, and also saves a lot of wastage of the materials also. And eventually, it saves a lot of time and fast track the delivery, so the patient can be fitted much quicker, knowing the fact that it is going to fit because it is ensuring the precision fitting. So it's a definitely is a one of the major game changers for the orthopedic or periodic footwear profession. Thank you, Danielle. And I will be keen to hear a bit more about some of the interesting cases that you have implemented periodic information modeling or parametric design, some of the challenging cases, then you achieve some exceptional outcome. If you can please give us some examples. I have seen some of your presentations and cases in the conferences. You can pick anyone for our audience. So yeah, over to you, Danielle.
Okay, so this was a complex case which I
Mhm.
started at my previous workplace. Okay, so I like a lot this case. It could be a school case
Yes.
because with such kind of cases we can easily implement it. Why it is so complex?
Mhm.
Because this young lady, because of pathology from younger time, okay, so
Yeah.
she has all the lower limbs rigid and
Okay.
has equinus on both feet. So practically she cannot stand upright without
Yeah.
shoes.
Correct. Or without
In
support.
this case, you cannot, yes, in this case, you can't measure plantar pressure.
Correct.
It
Yeah.
is not easily to scan
Correct.
because in all cases we are seeing a lot of technology applied with
Mhm.
feet which can use that technology. But
Mhm.
this is why I like pedortics, because sometimes you cannot apply usual technologies. Okay,
Yes.
many times I see on LinkedIn, for example, a
Mhm.
pressure map which is transferred into a lattice structure. It's not the case here. Okay,
Correct.
so unfortunately, in my country, we don't have a pedortic school like in Australia. So it was very hard for she to have a normal pair of shoes. And in the images from above, you can see the original shoes, which okay,
Mhm.
normal shoes with a wedge inside. And here on the left, you can see the shoes which were made through traditional method at
Yeah.
my previous work of place. But in 8 years, when I meet her again,
Mhm.
you can see how it looks the shoes, because at least in my country, nobody wanted at least to copy and transfer
Correct. Yeah.
the initial shoes in another pair.
Yeah.
Probably in Australia or Germany or United States, she
Mhm.
would benefit from a traditional solution. But this was my advantage because I built all the model
Mhm.
around this case. Okay, and the idea it was that I was a single. I don't have employees. How
Okay.
can by myself manage all the process? Okay,
Okay. So that
so
means that you have to make the
here
shoes,
I
everything
started
yourself.
with pedotic information modeling, which means grasshopper, which is a language, visual language. Okay, so I have created this parametric visual grasshopper code in
Mhm.
order to design the shoes. And in this slide, you can see the on the left the fully 3D
3D
printed
printed apart. Yeah.
shoes. Okay, and on the right side, it is important. It is a collaborative project with the Romanian artisan.
Okay.
Practically on the right side, we have just the upper from leather, and the
Yeah.
rest, the foot orthotics and the midsole, are 3D printed. So here
Fantastic.
the idea is that I see many time pedortists somehow being intimidated by technology. This, from my point of view, is because of the school, of the curriculum. Okay,
Yeah.
so we can start easily with insoles or with shoe last or with midsole, and at the end we will like the feeling to manage all the variability, and I'm sure we can go where it is possible to the fully printed shoe.
Okay, on the picture on the left hand side, the 3D printed shoe, the Velcro strap, that's also 3D printed, Daniel?
Yes, it's 3D printed, and I have tried to make a special design for ventilation.
Oh, fantastic. That's a very much personalization. I like the idea. That makes a huge, even actually, it doesn't look like a 3D printed part.
Thank you.
It looks like a prefabricated, some sort of fabric or other kind of material. So, well done. Really, it's another level of design and thinking.
It is fully 3D printed, and not only printed, but it was worn several months around I don't know exactly, maybe 5,000 steps or something like this.
Fantastic. So
I
this
have
could be
presented the
the one of
data.
the
So
this could be the one of the very first really worn orthopedic footwear which is 3D printed by a real patient. Well done, Daniel. Okay, and how was the patient's feedback when she saw the footwear is 3D printed? Was she excited or was she very nervous or a bit of both?
okay, if you are looking at 3D printed shoes market,
Mhm.
you look, for example, you'll observe, for example, Zellerfeld platform,
Yeah. Yes.
which are making,
From
let's say,
USA.
normal shoes for young people.
Yep.
Okay, so here it is a huge difference, because in the orthopedic field, the patient are still like pedortists are still so attached to the traditional footwear.
Manufacturing method.
For
Yep.
them, leather as materials inspires safety. So you don't have to expect a patient who are seeing a fully printed shoe, orthopedic shoe, to accept it as young people will accept, let's say, a Zellerfeld shoes. This will be
Yep.
a huge mistake. Okay, so the problem of my patient was one, let's say, on the basic level. He simply couldn't make a new pair of shoes because nobody wanted. So the
Correct.
first reaction was a very positive one, because she got a new pair of shoes.
Correct. And it took the initiative
Okay,
to help her.
but yes, she liked the design, but for sure it is still attached to the leather method, because these inspire much more, let's say, comfort.
Correct.
So for those who want to try printing shoe uppers for
Yep.
orthopedic footwear, my advice will be to wait for let's say, a very positive feedback, because it's not just about printing, but it's also about creating the acceptance of this type of product.
Correct. Yeah. That's a huge leap. And we know that 3D printing of fashion footwear is becoming a trend now. Still, there are limitations in terms of materials, in terms of design, what could be designed and can be sustainable. But a lot of companies are trying, a lot of innovators are trying, which is a great thing. And as per my knowledge, you are the first one introducing this to the orthopedic footwear. So, which has been amazing, and I'm sure there is a long way to go. And so I have been seeing some recent advancement, Daniel, that robotic implementation of robotic engineering in footwear manufacturing, where the midsole or outsole is 3D printed. Then they have been a robot has been actually doing the knitting of the upper over that. So that is creating something very appealing product. And I guess the current challenges we have in some level in terms of filament or in terms of technology, the full upper, or sometimes it could be the opening of the shoe, bit challenging for some conditions. But what do you think about the new method of combining 3D printing and robotic engineering for manufacturing footwear?
Yes, there are new developments now which are really fascinating,
Correct.
with knitting, but also if you are looking at Oxman shoes or on
Hmm.
sport shoes. But I'm fascinating by this but in the same time, we need something which is accessible to us as individuals.
Correct. Yeah.
If we are speaking about knitting, yes, it is right. I have tried, but you cannot buy your knitting machine. You cannot be independent. Okay. So it is very possible if you just want to knit one pair of uppers where left is different by the right, those who has knitting machine to tell you that they cannot do just one pair. You need hundreds of pairs to be efficient.
Yeah, that's a limitation.
Okay, yes. So in my work, all the time I was fascinating, for example, by metamaterials. Okay, this is a metamaterial. Okay, but this is done. I can't afford, and is now expensive. So I cannot develop myself. So what was important for me was to have an accessible technology.
Okay, now that's a great point, Daniel. Accessibility and availability to small business owners or who are running pediatric practices or clinicians who are running the team is solo. Yes, sometimes accessibility also depends on which part of the world they are located. That could be a challenge also. So we both are fortunate that we have accessibility in terms of market, but many of our colleagues around the globe, they don't have accessibility towards to this kind of technology or materials. Where the access is a bit limited, Daniel, what do you suggest in terms of 3D printing machines or filament? What could be easily accessible for our colleagues any part of the world? Because I know that you have been doing this for a long time and you have tried different machines, different technique, different filaments. So I'll be keen to hear your advice for our colleagues who has limitation in access in terms of technology or may not have all the technology available.
This was my problem too, because in my country I don't have a Hewlett Packard multi-jet printing machine.
Yeah.
Okay. So for example, these uppers were one of my first uppers, but was printed abroad, not in my country. Okay. So when you are starting with this, you will not afford to make many samples in order to define your design.
Correct. Yeah.
So because of this, I focused after the first enthusiasm was at its maximum intensity. And when I realized that I can't afford to print on expensive machines, I focused just on FFF printing, which is accessible. Okay. So at the end, instead of a metamaterial, okay, I think this is printed on a carbon machine, carbon printing. You can see it in Adidas Futurecraft midsole. For sure, it is of high quality. Then I focus on what I can do on the FDM printing. And this is the gradient stiffness, where I can modify the stiffness locally. So my advice would be to focus on affordable 3D printers and also software.
Can you name some brands?
For example, if we are looking at Zellerfeld shoes, they have a FFF printing. So this gives me hope that FFF printing could be enough in this stage to develop ourselves. The idea is to focus on what you can afford.
Okay, great. Thank you, Daniel. And so I'm curious to know your feedback on the performance or mechanical performance of the filament that you have been printing by using FDM machine with the gradient stiffness, and how does it compare in terms of performance with the metamaterials that you showed us earlier was printed in a high-end printer?
I think for foot orthosis, the printed foot orthosis on FDM FFF technology are very good in terms of usability.
Okay.
For sure, if we are looking at Zellerfeld shoes, also for midsole, it is good in terms of usability. For
Okay.
sure, the metamaterials printed
Mhm.
on a higher price
Printers.
machine and
Yep.
with other type of technology, not FFM,
Mm-hmm.
seems to be much more durable in this
Okay.
moment. What is important is to be accessible because
Okay, Daniel, how long it takes to design a pair of shoe from the beginning until it is ready for printing? For example, if we look at the patient case you have shown earlier, how long normally it takes to design the whole footwear, including the orthotics, midsole, upper?
so with experience in the manipulate the code, it could take uh, let's say maybe 1 hour, 2 hours, maybe,
That's
or
actually,
even faster
yes, that's great.
to
Even in a
design.
traditional, correct. If we are looking at the traditional method, it takes a lot longer. Even for a very experienced person, it takes longer if it is done traditional way. So it definitely saves time. And in terms of printing, normally how long it takes
And
to print?
here, in the design phase,
Mhm.
you will obtain the files to be printed, so you
Yep.
don't have to make other manipulation. Design means
Correct.
that at the end, you
Yep.
have the files
Yep.
which are take from the computer and go to the printer. In terms
Correct.
of the printing time, yes,
Mhm.
this could be a problem because it could take maybe if you have two printers, for sure you have the
You can
time
print as a
at
pair.
half. It depends.
Yeah.
If you
Yeah.
want to make a shoe which with the as it could take maybe between I don't know 1 day and 2 days depending on the size. If you
Yes.
are dividing the shoe in uppers and midsole and you
Yep.
have four printers, then you can print it in 1 day.
Okay.
But uh, but we are at the beginning.
Mhm.
I'm sure in time the printers will be much more
Yes.
faster.
Much more faster. Correct. And that
So
will
I'm
save a lot
sure
of
this
time.
time will be reduced. But
Yeah.
but you have to think at one thing which is important.
Hmm.
You have to consider one important thing. While
Hmm.
the printing print
Yeah.
your shoes, you
Hmm.
can do other things. You can learn, you can spend time with your family or with your friends,
Correct.
or you
Correct.
can learn grasshopper. When you
Correct.
are
Yeah.
grinding, you just grind. When you are
Correct.
stitching, you just stitch. You cannot
Correct.
grind and
Multitasking at the time.
stay with friends or learn grasshopper.
Correct. Correct. Yeah. So we can let the machine to do the
So
job
you have
and we
much
can
more
enjoy on time.
time for you to develop yourself.
Correct. Yeah. Now that's a very important point. Okay, Daniel, I can see also on LinkedIn that you are very active in your group that you have created. I think it's called that 3D printing medical footwear community. Correct? What is your experience so far? Do you see a
Yes.
big surge in number? Like a lot of people are interested in and joining and contributing.
Till now, I have seen there are a lot of people who are coming. Uh,
Okay.
till now, I'm the main contributor, and
Yes.
really, I would like to have much more contribution because I know other people with the interest which are doing great things, but
Hmm.
still not contribute. For example, I saw in Australia David Sutton who has printed
Yes.
the and now a sort of ankle foot orthosis. I would like
Yes.
him to participate here and other people
Okay.
because in this way we can experience. So
Correct.
this group was created with the idea that it is possible to do this.
Okay, now that's great. Well done, Daniel. You have taken lead in many aspects. Well done to you for your exceptional contribution. And on this point, I'm keen to ask a question from your experience because you came a long way from implementing parametric design, bringing from another industry where your previous engineering degree helped to implement new technology, which is not new for other industry, but new for the pediatric profession or medical device profession. So what do you see in future? Why are these things are taking medical grade footwear practice or orthopedic footwear practice, or in countries like Australia we call pediatric practice? How this technology like parametric design, pediatric information modeling, and 3D printing will take the profession or the way we practice?
Here, I would like to mention that have graduated 30 years ago. Okay, so my programming knowledges are very limited and I have gained them 30 years ago. So I am not expert in the programming, but this is very important that visual programming things very to be done, because I saw many time reaction for pedortists. Oh, computer programming is not for us, because in visual programming you don't need to know a language, programming language. For sure, in architecture or building, sometimes you need much more complex software, much more complex routine. Okay, it's not the case here. So this is very important. It will be easy to be implemented in school, because our problem is with the school. If you don't have the basic knowledge from the school, it will be hard for you to develop yourself in this part. So from my point of view, what brings us this parametric design, and here if we can see the last image, it will be great. Okay,
sure.
If you can show the last image. Okay,
yeah, it
so
is
what important is that we can create new materials. Okay, so here you see, you think when you are using an AVA or polypropylene material, you don't think its structure. You just take it from the store and use it.
Correct.
Here with metamaterials, you have to think the material, and this is one most important thing. You don't just use an existing material. You create one, and for sure this will raise your profile as a professionist in health field. Then with these new technologies, you can bring a new design. Here, for example, it is a collaborative project with a designer. For sure, I'm not able to create that design, but I am able to give the input data for a designer in order for he to improve, and maybe for I don't know, maybe for a niche or for a segment of the orthopedic patients, this will be much more attractive than the traditional one. And here I will see that I think we have a problem with the design, because I didn't saw any pedortics book with a chapter about design principle. And here I not discuss just about the technical part, but also about aesthetical part. So with this computational design, you can create a new design. You can create your own materials. You can implement things which you cannot do to traditional method. So all this parametric design, it is a continuity. It's something to be added to the traditional, not to replace it. And this is important.
Correct. Yeah, we know that in our traditional manufacturing method, we have challenges when we want to optimize pressure offloading. We want to reduce the weight, which is sometimes a major factor for many of the patients group we deal with, the weight of the shoe. And if we are using a traditional materials, it can end up being heavy if we want to enhance pressure offloading. So obviously, this metamaterials, the lattice design, allows us to keep it lightweight, to make it more effective in terms of weight distribution and ensure optimal offloading. And I have seen that some brands, they're adding some skins around it to give a different texture, which is aesthetically become even more exciting. So definitely this is the way to go for future, to make it more functional, achieve our treatment goals in terms of pressure offloading, fitting, and also another important factor is the patient adherence. So patient feel more excited about using the footwear, which is a big challenge in the current practice. So I agree with you, Daniel. That's definitely will make a huge difference in terms of how we practice, how we look at patient adherence perspectives, how we want to achieve our goals in terms of engaging the patient more and letting them to use it more happily and being more functional. And at the end, it leads towards the better quality of life for the patient. So definitely, this is a new.
I strongly believe this, but we need much more courage to try, to experiment, to fail. I failed many times, not so many
Okay.
times with 3D printing, but with the proper information, we can lower the time of our advancement, personal advancement, with sharing experience. So we have to try. And the one problem which pedortics has, from my point of view, is the curriculum of the school.
Yes.
So I followed the main schools. There are a few pedortic schools in the world. Is
Mhm.
Australia. I know it is at the university level. I hope it will start again. Okay. So
Yeah.
that curriculum, it is excellent. But what is missing in that curriculum is this part of med design, of visual programming. It should be started from the school with simple things, because I will give you just a simple data.
Mhm.
To have a software like Rhino,
Mhm.
it costs you, let's say in euro. I don't know your currency. It's about 1,000 euro. Okay,
Which
any
will be
proprietary
around
software
1,500.
which is much more complex, for
Yeah.
sure,
Yeah.
costs much more than that.
Yes. No, I'm sure the academic committee
So
will be looking at.
simple with this investment.
Yes, so I'm sure that our academic committee for the pediatrics course in Australia will be definitely looking into the 3D design, lattice design, and 3D printing aspects, and also the visual programming aspects to personalize and device design as another modality, and together
I
with the conventional method. Because they need to learn definitely the conventional method and also the advanced method also to be contemporary and to make the most of the modern technology that is available. So thank you for the suggestions, Daniel. So we are towards the end of the of our podcast, and let's summarize from my point of view what we discussed. And so obviously the parametric design something new for the pediatric profession, but it is not new for the mainstream engineering discipline. So this is a good example that if we are proactive, we can bring knowledge from other industry and enhance our practice in pediatrics or medical device design. And we can learn from our other colleagues what they're doing innovative. The same way we can share what we do something better, we can share with them. So that's a better way to learning. And also ultimately the patients are the winner. They get a better product, they get a better service. And also the parametric design help us optimize our manufacturing, brings more visibility, more precision for the clinician, gives more clarity, more assurance towards
Yes,
achieving our treatment goals. And also at the end, patient is happier, more excited, more engaged. So that's the benefit. And to implement that, we need to focus on our pediatric education, how we prepare our
yes,
future leaders in the food health, in the pediatrics profession. They can learn and bring new knowledge into the profession. So ultimately, the patient become the winner. Thank you, Daniel. Now over to you. If you want to please summarize the discussion point today between us.
yes. For me, this discussion show me that there is an interest in the pedortic community for this new technology. Your
Exactly.
invitation is
Yes.
also a motivation for me
Correct. Thank you.
um, to try again to uh, ask pedortists to have courage and to
Correct.
try to learn, because it's not such difficult. And
Correct.
with this new technology, if we will start somehow, we will be able to raise our profile as a health practitioner.
Correct.
We will be much more happy because we can do things in other ways. So, pediatrics is such a complex and a beautiful profession. It is
Correct.
very nice to integrate all this technology in a
Yeah.
single solution, which will help and motivate us as person.
Exactly. Thank you so much, Daniel. Thank you for making the time to join us. And it has been wonderful to have Daniel, and my special gratitude to Daniel for making that special effort to join in the early morning and waking up early morning to join us and talk to us. It means a lot. It also shows Daniel's great passion about the profession, his great passion about implementing new technology, implementing his greatest wealth of knowledge to enhance the patient care, to help the patient, and to help the patient to live better. So, thank you again, Daniel. I really appreciate your time and effort, and keep doing the best work you have been doing to enhance the profession and enhance the patient well-being. Daniel, you want to say a few words to the audience, please?
Thank you very much also for inviting me here. And if any of your followers wants to have much more information, you can guide them, or you can send emails to me, and whenever can, I will answer. I'm interested to see much more pedortists involved in this process. Thank you very much for your invitation,
Yeah.
and I want to wish you success with your initiative to grow the profession.
Thank you so much, Daniel. I'm sure there will be a few more or a lot more new members in the LinkedIn group of the 3D printing technology in orthopedic footwear after this episode. Thank you again, and we'll catch up soon again for new topic and new exciting things, and hear from you about your innovation in down the track. And I'm also looking forward to catching up with you soon in one of the conferences somewhere, some part of the world. Thank you so much, Daniel, for your time again.
Yes, for sure. Thank you very much.
Thank you. My pleasure, Daniel. Viewers, thank you so much for your time and support that keeps us going to continue these podcast episodes. In future episodes, we will be bringing more new guests from different parts of foot health profession who will share their experiences and wealth of knowledge with us, talk about their passion. They will talk about their special outstanding achievements, what they have done through the professions, and will be making us informed about the exciting innovations and what that means for the future of food healthcare. And we welcome you to join in the future episodes also. Please keep an eye on our social media and on our YouTube channel for the new information about the new episodes. Until then, stay safe, look after your feet, and always remember healthy feet are the foundation of a healthy life. Thank you, everyone.